Good afternoon, teacher and classmates. Our team made a LED lamp with recycled materials. Our team is made up of Hugo, Fadei, Ivana, Stephanie, Brian, Alejandra, and Paola. The materials they used were high luminosity LED diodes, tongue blades, a solar panel, cables, screens and nuts, and our lamp will be present to you below.
One. We begin by assembling the structure of what will be our LED lamp. We start by joining two tongue depressors and make two holes on the sides using a drill. Have the two holes in the tongue depressors, we continue by doing the same with 4 more tongue depressors, 2 small holes on their sides with a drill. Once we have the tongue depressors ready, we will begin to assemble our lamp structure, joining the two tongue depressors glued to the other tongue depressors by means of the little holes. Putting a small screw, I tightening it with a knot so that it does not come out. Here we are cutting the base of the lamp. Now the structure is being assembled so that it can move and accommodate. Then, we try the circuit with the solar panel. For the connections, we connect the LED spotlight to the solar panel, since what we want is that the solar energy helps us to use a renewable energy. We also connect a resistance. Finally, we made the final circuit connecting the cables of the solar panel with the LED that did work, and a 200 ohm resistor. Always paying attention to connecting the positive and negative poles correctly. We tested its function and it was successful. We did the calculations to verify energy savings using LEDs. For a circuit, we used a 5-volt solar panel as a voltage source, a 3-volt and 20 mA white LED, and a 200 ohm resistor. First, we calculate the total current of the circuit with Ohm's law, which is 0.25 amperes. Next, we calculate the electrical power by multiplying the voltage by the total current, which results in 1.25 watts. With this data collected, we made a comparative table with the current consumption and the electrical power of a normal bulb. A normal bulb uses about 120 volts and its power can vary between 120 watts, 100 watts, and 60 watts since it uses alternating current. The current intensity gives us 0.83 amps, and with Ohm's law, we discovered that it needs a resistance of 144.57 ohms. Regarding the analysis of the savings in the part of the current consumption and putting the data in a table, the normal focus voltage source provides 120 volts and uses 102 watts of electrical power, being its consumption of 0.83 amps. On the other hand, in our circuit, we provided the LED with a voltage source of 5 volts and it only used 1.5 watts of electrical power, so it only consumed 0.25 amps. Now, if we take a percentage, 0.83 amps from the normal bulb equals to 100% of the energy consumption, and 125 amps equals to 32%, which means that let's save about a quarter of the energy that ordinary bulbs consume. In common bulbs, 100 watts are consumed in 1 hour, whereas in LEDs, 1.25 volts are consumed in 1 hour. If we carry out an analysis per hour in any house where 5 bulbs are turned on at the same time, we first do the calculation with the common bulbs, multiplying the 100 watts by 5 bulbs, giving this a product of 500 watts per hour. As for the LEDs, doing the same multiplication with 1.5 watts, we obtain that it only consumes 6.25 watts per hour. This is an abysmal difference, and it is demonstrating that by making a final percentage where LEDs have an advantage of 90-80.75% of saved energy. We also did the calculations with a 9-volt battery we used and a 60-watt bulb, confirming the LED efficiency result.
What is a LED diode? A LED diode is a diode that, in addition to allowing the current to pass only one way, in the sense in which the current passes through the diode, it emits light. When a diode is connected in the sense that it allows current to pass, it's said to be directly polarized. In addition, the word LED comes from the English light emitting diode, which translates into Spanish is diodo emisor de luz. One of the characteristics of LED diodes is that LED diodes have two connection pins, one long and the other short. In order for the current to pass an emitting light, the long light must be connected to the positive pole and the short one to the negative pole. Otherwise, the current won't pass and it won't emit light. In the following image, we see a LED diode inside. And you may wonder, how does it work? The operation is very simple. When we connected the LED diode with direct polarization, the top semiconductor allows the passage of current that will circulate through the pins, cathode and anode. And as it passes through the semiconductor, this semiconductor emits light. Depending on the material that the semiconductor is made of, it will emit light of a different color. Thus, we can obtain LED diodes that emit light of a different colors: aluminum, gallium, indium, phosphor, etc. There are many color LEDs. RGB LEDs are diodes that have three semiconductors, each with a different color. The colors are the primary colors red, green, and blue. If we control this mixture of colors, we can obtain an immense range of colors in the LEDs. To control the colors, it's only necessary to pass more or less current through one or the other semiconductor. For example, if current only passes through red and green, the color we obtain will be yellow. While a normal bulb has a useful life of about 5,000 hours, the useful life of an LED is greater than 100 hours of light. We are talking about 18 years of continuous light emission. 18% of the energy that a LED consumes is transformed into light. However, conventional bulbs only transform 20% of what they consume into light. Everything else becomes heat. Another advantage is that the duration time is much longer. Some advantages of the LED diodes are: the first is that they consume less energy than conventional lamps because normal bulbs emit light but also heat. Heat is energy that we lose. What we want is light, no heat. Science LEDs also lose energy in the form of heat, but in much smaller amounts. This means that almost all the energy they consume is used to give light and not heat, with the consequent saving.